Proxima b, a planet remarkably similar in size to Earth, captures the attention of scientists worldwide. This striking resemblance alone sparks curiosity and excitement. When a planet mirrors Earth's dimensions, it prompts speculation about whether it could harbor Earth-like conditions conducive to life. However, caution is warranted before jumping to conclusions. Unlike Earth, Proxima b does not orbit a star akin to our Sun. Instead, it revolves around Proxima Centauri, a red dwarf star that is smaller, cooler, and emits significantly less light than our Sun. The nature of a planet's host star profoundly influences its climate, temperature, and potential to sustain life. Intriguingly, Proxima b resides in the habitable zone, the region around a star where conditions are neither too hot nor too cold, potentially allowing liquid water to exist. Water is often considered the cornerstone for life, making ascendancy to the throne, where the monarch rules with absolute power, is a term that signifies a region where conditions are just right for life, much like Proxima b's position relative to its star. Yet, enthusiasm for Proxima b's prospects must be tempered. The planet is likely tidally locked, meaning one side perpetually faces its star, basking in constant daylight, while the other is shrouded in eternal darkness. This creates extreme conditions, one side scorching hot, the other frozen solid, hardly an inviting environment. Additionally, Proxima Centauri is a volatile star, prone to unleashing powerful solar flares, massive energy bursts that could bombard Proxima b with harmful radiation. These flares might erode the planet's atmosphere or render its surface inhospitable for life due to intense radiation exposure. Despite these challenges, Proxima b remains a focal point of scientific intrigue. As one of the closest Earth-sized exoplanets discovered, with the tantalizing possibility of liquid water, it stands as a prime candidate in the search for extraterrestrial life beyond our solar system. Red dwarf stars may not dazzle with brilliance or boast the grandeur of massive stars featured in space documentaries, nor do they vie for cosmic drama awards. Yet, their significance is undeniable. Red dwarfs are the most prevalent stars in our galaxy, meaning a random point in space is likely near one. These diminutive, dim stars burn their fuel at a leisurely pace, enabling them to shine for billions, sometimes trillions, of years. This longevity provides orbiting planets, like Proxima b, ample time to potentially foster life, a critical factor for astrobiologists. Due to their cooler temperatures compared to our Sun, red dwarfs have a habitable zone much closer to the star, where liquid water might persist. Proxima b, orbiting the red dwarf Proxima Centauri, sits squarely within this zone, suggesting that despite the star's faintness, the planet could be warm enough to support water, and by extension, life. Proxima Centauri itself emits a mere 0.05% of the visible light of our Sun, barely a flicker. But Proxima b's proximity means it receives about 70% of the infrared energy Earth gets from the Sun, potentially sufficient to maintain habitable temperatures. However, Proxima Centauri is a flare star notorious for sudden, dramatic brightening up to 100 times its usual intensity, unleashing intense radiation bursts. These flare-ups could disrupt Proxima b's atmosphere, posing significant challenges to any potential life forms attempting to thrive there. In 2020, the Breakthrough Listen project detected an enigmatic radio signal dubbed BLC-1 emanating from the direction of Proxima Centauri, the closest star system to Earth. This signal, characterized by a narrow bandwidth and a drifting frequency, suggested the hallmarks of a deliberate transmission, igniting speculation about extraterrestrial origins. However, experts swiftly attributed it to terrestrial radio interference, dampening the excitement. Yet this explanation raises questions. The signal was pinpointed to Proxima Centauri's location in the sky, unlike typical Earth-based interference, which tends to scatter or recur across different sky regions. BLC-1 appeared only once, never reappearing in subsequent observations, and did not match any known satellite or terrestrial source. Its frequency drift, indicative of a transmitter on a rotating or orbiting body, added to the intrigue but was quickly dismissed. The official stance posits BLC-1 as a human-made anomaly, possibly from a phone tower or another unidentified device, though no specific source has been confirmed. This leaves room for skepticism, as the signal's unique, focused nature challenges the interference narrative. The incident served as a learning experience for the search for extraterrestrial intelligence, SETI, refining their methodologies. However, dismissing the possibility of alien origins outright seems overly simplistic, leaving lingering questions about what BLC-1 truly was. Imagine the global uproar if scientists confirmed alien life or advanced technology on Proxima b. Such a discovery would redefine humanity's place in the cosmos, proving life can thrive in environments vastly different from Earth's, thus diminishing our planet's uniqueness. Beyond that, evidence of alien technology could revolutionize our understanding of science, engineering, and human progress. A civilization with distinct technological advancements could offer insights to accelerate our own development, an exhilarating prospect. Currently, we're at the dawn of this exploration, with scientists employing powerful telescopes to study Proxima b remotely. Its tidal locking presents a unique challenge. One side perpetually bathed in sunlight, the other locked in darkness, creating extreme temperature disparities. Yet, a narrow twilight zone between these extremes might offer stable conditions for liquid water, and thus life. Intriguingly, peculiar signals from the planet's dark side fuel speculation. Are they natural, or could they hint at an alien civilization? These questions drive the quest to understand Proxima b, pushing the boundaries of what we believe is possible. Proxima b orbits Proxima Centauri, a red dwarf over 4 light-years, approximately 25 trillion miles, from Earth. Even our fastest spacecraft would require tens of thousands of years to reach it, making remote observation our only option. Conventional telescopes struggle to discern distant planets, especially those near bright stars, akin to spotting a firefly beside a spotlight. Advanced tools like the James Webb Space Telescope, which detects infrared light, offer hope by potentially analyzing Proxima b's atmosphere. The upcoming Extremely Large Telescope, ELT, set to debut in Chile in 2028 with a 40-meter mirror, promises unprecedented light collection and sharp imaging. Scientists anticipate the ELT could analyze light reflected from Proxima b to detect molecules like oxygen, carbon dioxide, or water vapor, potential biosignatures. A 2025 study suggests the ELT could distinguish between living and barren planets in just 10 hours of observation, a monumental advancement. If Proxima b possesses an atmosphere with life indicators, the ELT could provide answers to the age-old question, are we alone? Elon Musk, through SpaceX, revolutionized space travel with Webb. Reusable rockets, slashing costs and enabling ambitious missions. Founded in 2002, SpaceX aimed to make space exploration affordable and expedite human travel to Mars. Its reusable rockets, which land and relaunch like airplanes, have paved the way for grander ventures. While Mars has been Musk's focus, Proxima b has recently captured his imagination. Located in the Goldilocks zone, where temperatures allow liquid water, Proxima b is tantalizingly close in cosmic terms. A 2018 NASA study by Anthony Delano suggested the planet could sustain surface water, with newer models proposing oceans up to 200 kilometers deep, far surpassing Earth's. Musk's tweet calling Proxima b practically next door reflects his enthusiasm. With SpaceX's reusable rocket technology and rapid advancements, missions to study exoplanets like Proxima b are no longer pure fantasy. Could it become a second home? While premature to say, Musk's vision and SpaceX's innovations bring the possibility closer to reality. The prospect of reaching Proxima b over 40 trillion kilometers away is daunting. Voyager 1, our fastest spacecraft, would take 80,000 years to arrive, longer than recorded human history. NASA's Directed Energy Propulsion for Interstellar Exploration, DEEP-IN project, offers a revolutionary solution. Tiny spacecraft propelled by Earth-based laser beams akin to sailing with light instead of wind. These ultralight sails could reach 20% of light speed, reducing the journey to 20 years, a human lifetime. Einstein's theory of relativity introduces time dilation, where time slows for fast-moving objects relative to stationary ones. For astronauts on such a craft, the trip might feel even shorter. This principle, already applied in GPS satellite clocks, could make interstellar travel feasible. With SpaceX's reusable rockets, NASA's Deepin, and Einstein's time-bending, physics visiting Proxima b is transitioning from science fiction to a tangible future. Should we reach Proxima b, its hostile environment, due to tidal locking with one side in perpetual daylight and the other in darkness, poses significant challenges. Terraforming or reshaping the planet for human habitation would be essential. An artificial magnetosphere could shield Proxima b from its star's intense radiation and flares, mimicking Earth's natural protection. Altering the atmosphere with greenhouse gases or artificial clouds could distribute heat more evenly. Addressing the frigid dark side might involve transferring heat via underground pipes, engineered ocean currents, or high-tech vents. If oceans exist, their currents could naturally redistribute warmth as salty water freezes at lower temperatures. Artificial lighting on the dark side, powered by solar panels or orbiting mirrors, could support plant and human life. Artificial intelligence would be crucial, running climate models, adjusting systems, and overseeing construction. Terraforming Proxima b is a colossal endeavor, but it could transform science fiction into reality. A speculative theory suggests Proxima b may have once supported life before volcanic eruptions, frozen oceans, and extreme temperatures altered its fate. Its proximity to its star likely caused one side to bake, while the other froze. But in the past it might have had a stable climate with liquid water and a robust atmosphere. Volcanic activity could have disrupted this balance, spewing gases, lava and ash that triggered extreme climate shifts, boiling some regions and freezing others. Global cooling may have turned oceans into ice sheets. Yet beneath these frozen depths, protected pockets of water might harbor surviving life forms, akin to Earth's deep-sea vent ecosystems, thriving in darkness under crushing pressure. Thawing Proxima b's oceans and restoring atmospheric balance could reveal traces of ancient life preserved for millennia, offering a glimpse into what the planet once was before its catastrophic transformation. Unusual light emissions from Proxima b's dark side defy expectations, unlike typical atmospheric or reflected starlight. These anomalies prompt speculation about artificial origins, possibly alien technology, hinting at the existence of an advanced civilization. Such a discovery could unveil intelligent life beyond mere microbes, raising profound questions about their nature, communication, and intentions. Even if natural, these lights could reveal novel weather patterns, unique atmospheric chemistry, or unknown energy sources, expanding our understanding of exoplanets. The challenge lies in Proxima b's distance and interference from its flare-prone red dwarf star, which complicates observations even with advanced tools like the James Webb Space Telescope. The forthcoming Harmony instrument, part of the extremely large telescope, promises sharper images and better data, potentially confirming water, organic materials, or further anomalous emissions. Each discovery, however small, edges us closer to answering whether we are alone in the universe.